Hello everyone, my name is Martin Meyer, as it was mentioned several times. I'm one of the creative specialists at the Foundry. We are the guys who are presenting the software. And today we'll talk about CARA, or I will show you CARA VR and the stitching toolset, and also we'll talk about the latest features in MODO 10, the whole 10 series. Before we do all of that though, I would like to show you the amazing work that our clients do with our software. We are mostly active in the VFX field, but you can actually get to see what people are doing. Just a second. I think we need sound. In the machine, actually, sorry, this is connected, just little glitch. Yeah, no, it needs to be switched.
Okay.
So let's just set this as a default device and new. Let's try again. Maybe it did.
Should be on. It's this one, yeah.
No,
Yep.
This one, okay.
Yep.
All right.
And now you're correct.
Let's give this. Here we go. Awesome. Yay. Excellent. So we'll start with CARA VR. It's the 360 stitching toolset that allows you also to composite inside of a NUKE. It's a NUKE plugin, and I will take you through the whole workflow sort of directly in the application. So here I have a NUKE, and I'll just open up a script with some of my footage. Let's say this one. And what we have here, right here, is, let's get rid of everything, is a capture. This is, in this case, it's quite a few cameras, and it's a stereoscopic capture of 360 sphere. These were GoPros. Initially, you can do this practically with any cameras arranged in a rig. So at this point, we have just the footage that was captured, and the first thing we need to figure out is how the cameras were arranged in a 360 or in the rig to get the proper spherical projection from these cameras. For that, you can use the camera solver. That's the first node that you will need to start dealing with spherical captures inside of NUKE. So I'll just add that node, and you'll see that all the cameras are stacked up on top of each other. It found 13 cameras, including the 0 one. And if I just look into the 3D space, these are all the cameras on top of each other. CARA or NUKE doesn't know anything about the rig at this point. So initially, before I actually do the solve, it's GPU accelerated. You can use some of these presets. These are currently the known presets. You have few presets for GoPro solutions. We have also preset for Nokia Ozo. But generally, if you don't know or if you have a custom rig, you really don't have to input these numbers. This is just something that helps CARA to give you the solution for the rig. Another thing that I can do is set up the lens distortion. So I'll just set it to optimize for a single. That will be optimized for one frame. All the cameras are the same. The focal length never changes, so I don't need to optimize it on per frame basis. And I'll set my output format. You can do this on a globally through the script or for the solution. So for the sake of speed, I'll just set this to a 2K lat long projection. So, and with this done, I'll just hit match. And right now, CARA is going through all those cameras, all that footage, and it's trying to find correlation points, how those pictures relate to each other. It's a very similar process to, let's say, a 3D tracking. It literally finds areas or pixels that match between the cameras, and then it will give me some sort of solution. Now, this doesn't make a lot of sense, but the moment I hit the solve, it will actually try to figure out the rig for me. So after a short calculation, if I hide the points, I get projection. First thing is that since it had no idea how the camera should be laid out, if I hit tab, here you can see the layout. So now I actually get something that makes more sense. I have two cameras looking in every direction. I also get a really handy point cloud of the whole world. So you can use this to place 3D elements if you need to. You can just select the point and place it wherever you want to. So it analyzed the world essentially. The first problem that I see here is that the whole thing is upside down. That's very easily fixable. I can just go to the settings and adjust the orientation. So there could be problems. Not necessarily CARA with the way things were shot. You may not have straight horizon. There are many things that can go wrong, but luckily, since we are inside of NUKE and we have the plugin, we can fix a lot of things. So, for example, if I go to the adjust horizon node, I can start dragging around the horizon and fix things this way. This allows me to also constrain the rotation, and maybe I would like this board to be in the middle of the projection. So we can fix things this way. You can also fix and move individual cameras. Here I have all the cameras and their links, how they relate to each other. And one thing to watch for is the solve error threshold. So if I go to the points, actually, you see that some of them are red. Those are the ones that evaluated as with the higher error threshold that we allow them to have. So if you want to improve your solutions, you can always dial in this little number, and I can reject some of the points, and in general, the solve error should decrease because CARA will partially resolve the solution and will readjust the cameras. You can also hit refine and potentially help the layout of things. If you need to, this is fairly simple footage to stitch, mainly because you have a lot of features in there. There's lots of little areas where the solver can pick up and align the pictures together. If you don't have that, you can always just go ahead and start creating your own features directly. So for example, this point, let's pick something slightly better, something that actually is or could be a feature. Let's go somewhere here maybe, or perhaps here. And here I can see that, let's say I would like to match this in this camera, so I can adjust in camera 4 this area and maybe, for the sake of demonstration, this in camera 11. So you can help the solutions by introducing your own tracking points if you're dealing with green screen, for example, where there is not enough natural features occurring for the solve to happen. Good, so we have the initial stitch. The first and obvious problem is that there is lots of ghosting happening. So for that, we have another node in the system that fixes most of this. So I can just go ahead and add a camera stitcher. This node will go through, it will take the metadata and everything that the solver generates, and it will fix the overlap problem. Remember, we are dealing with 16 2K cameras, so on a small laptop, so the things are not the fastest. But now when I zoom into this, you'll see that most of the problems are gone. Well, they are all gone. So if I just disable and enable this, you can see the difference. It all aligned. The way this is actually done, it's pretty useful. I have the stream of cameras going through the whole system. So here I can see the individual cams being distorted. And we are using a stitch map to generate a distortion map, UV distortion map for each of those cameras. And you can intercept the data and fix the data directly here. Also, the stitcher generates an alpha to make the blend between the individual cameras. So once you have this, you can separate the ST maps, you can export individual maps, you can fix them. You have all the tools within NUKE to deal with practically any problem that the generation and dealing with spherical projections can kind of throw at you. So, but CARA is not only about stitching. You have also other tools like, for example, the Spherical Transform, which is GPU accelerated, allows you to actually simplify the compositing and beautifying of the 360 elements. So we can have a look at the way that actually operates. I'll just go here and I'll take my rendered version of that script and I'll put it right here. So if I would like to place something on, let's say, this board, that would be fairly easy. There is very little distortion, so I can just literally composite something in that. But if you look at the poles of the sphere, right here and right here, that might be an issue. So for that, I can just add a spherical transform to this really quickly and convert between various projections. So right now, I'm looking at this as a lat long. The input is lat long, latitude, longitude, and then my output is also lat long. But you can convert this to other useful way of projecting this particular image. So I have a cube map, fisheye, and rectilinear. So for compositing, rectilinear would be potentially one of the most useful ones. And this node also allows me, with using of hotkeys, I can start looking around this. I'll just drop the resolution so things are faster. I can look around this sphere that I'm in, the virtual sphere, and look at area that I would like to fix or add something to. This is only one potential way of working. And I can add my digital element there. This could be a 3D render. This could be really practically anything. So let's just add a little text. So let's just drop this here. actually rotopaint I want to use. Oops. And let's just write something in there really quickly. Hi. And if I look at this now, once we have it painted and added the element, we need to convert it back to the spherical view so it can be viewed on headsets or on phones, on a cardboard, on many other devices. And this spherical transform has a really nice convenient node that allows you to create inverted operation from what you're actually doing. So now I painted my high right here, and I'm converting it back to the spherical world. So as you can see, this is now on the ceiling of the whole sphere. And if I put it back on the, oops. If I put it back on the my previous render, I will get nice composite of whatever I just added previously. So you can separate individual cameras, you can add virtual elements. Just to prove the point, if I do the conversion again through a spherical map or through a spherical transform, to simulate the headset, so I'm going from rectilinear, I can look up, and there is my high element that I added in this section. So you have compositing tools, you have reprojection tools, you can also stitch the footage, and you can mostly fix if there are any problems with your 360 data. While all of that is happening, NUKE, we are using OpenVR to stream directly to VR headsets. So if you have a Vive or Oculus, you can be actually viewing the sphere directly on the device, which can help with the actual fine-tuning of whatever are you creating. So this is our latest plugin for NUKE, CARA VR. It allows you to stitch and composite in 360 environment directly inside of NUKE. Any questions about this bit? Anything VR related? No. Cool. Is there? I don't see. Yeah, I really see you.
Yeah, I don't think so.
Okay. Good. So now let's have a look at MODO. The whole year of MODO, we started sort of doing a slightly different approach. It's not about major releases with MODO. We are releasing throughout the year, and it's always focused on a specific workflow. So the very first set that you might find useful, I'll just open up MODO, was focused on digital matte painting. The next one was focused on games, and then we had a procedural modeling, and we'll have a look at most of these in separate views. So MODO is our digital content creation application. It allows you to model. It's an excellent modeler of texture, and it allows you to also render your assets. So the digital matte painting, one of the really handy tools that arrived with that release is the camera projection workflow that allows you to set up your cameras based on real photography and then put digital elements into it. I'll just load a clip right here, and I'll go to my folder and open up, for example, just look at this one. I'll start importing the images directly from here. So where are we? Sorry, it's on this drive. And also we have a new interesting viewport that allows you to actually appreciate all of that. So I can go to for example, this thing. Okay, so let's just load in image into the camera that we want to match. And I'll go to my drive here. And right on this. Here we go. So I have a bunch of pictures that I captured and I would like to match the camera to. So for example, let's just grab this one. And when I look through the camera right here, it will actually show up. Sorry, I loaded it into the wrong, I wanted to load it into the background. It will show up in the viewport, and now anything I do will be literally projected through the camera. There is few handy buttons that were added to the projections. For example, I can just set the resolution of the whole render from the clip that I'm using. Just by pressing this button, it will adjust the actual resolution on per camera basis. So every time I render through this camera, I can have an individual resolution based on the picture. You can also apply the EXIF data from camera settings, which can be really handy. And you can also extract the sun position from the EXIF data. If you have a GPS data on the picture, you can actually extract the position of the sun from that area. But let's just try to match the camera. So for that, I can jump to the match to background button, and I can give MODO some information about the scene. So the first one that I'll do is the x-axis, and that, let's say, should be pointing away from camera. So all I have to do is just start clicking here in the scene. I just enable the overlays, and something, little explosion. I'll load the camera again. Good. So match the background, and here I can start adjusting my camera settings. So first I can give it just two points for the x-axis. With the right click, I can really nicely fine-tune wherever this should be aligned to. I can double click here and give it another axis or another area. And another click will give me the Z. And again, that can be fine-tuned and placed to the scene. And if I just right-click on this, I can adjust a few things. And when I'm done with this, you can even adjust the lens distortion if you want to. But when I'm done with this, I can hit Set Camera for Matcher, and that will actually align the camera to the virtual box. So in perspective, if I actually enable the cameras, you'll see that it's looking at something in there. So if I go back and I want to model something, let's say remodel the box again, I can just start dragging around these points and it will align. Now, if you spend a little more time fixing it perfectly, it will align perfectly, but I just really quickly got the focal length of the camera, and I also got the average rotation or the focal interest of the camera. This also, so if you're placing something into a photograph, this can be a really handy tool to use. If I jump to the render and just hit a preview render, you'll see that the box is fitting perfectly. And if I place something right on it, just by, let's say, bringing up something from the asset manager, let's say I'll go to my interior and decorative appliances, and maybe let's just take this little ball. I can drop it directly on the sphere, on the cube. Let's take it out, and I'll make the cube or the projected object invisible, just to show you that the integration works pretty nicely. So I just add the item shader to hide it from the render really quickly, and just escape all of this. And here I can say not visible to camera. Sorry, I just didn't want to subdivide this. So on this, I will just say not visible to camera. Now I have a So now I have actually the ball that is perfectly placed on a box. Can move around, and I just refresh the render. Cool. So not only this allows you to quickly model based on some camera data, it also allows you to do projections on the objects themselves, which might be handy if you want to extract reflections and create the integration with the environment even more seamless. For that, we have a nice and interesting new type of parametric ink that is called a projection ink. So if I enable my camera right here, show it in the viewport, that's the one. I can select my projection ink, and with the camera selected, let's grab my airbrush. You can see that there is the image that I'm going to be projecting on each of those cameras that you're using. I can just start painting on my box, and you can see that that will take whatever the object is currently sitting on. So if you want to really get a proper reflections on the environments from the photographs, you can use this technique to really nicely, to help you with that pretty quickly. So this was the first release in the year, and it was focused on the matte painting and integration of photographs and real world and digitally created objects. The next one, we focused on the performance of the viewport, and it's all heading towards our effort to create a virtually environment that you will eventually be able to view with a virtual headsets. So if I just go to my Foundry, and so this is the drive. Let's go here. So I'll just open up this scene because the viewport inside of the whole 10 series was quite remapped, and it was made much faster and also way more accurate. So this is the general view that you could get from the integrated viewport. But now, well, we have the advanced viewport for few series now, but in the 10, it's faster and more accurate. It can do interesting things like real-time reflections. It can do ambient occlusion. Let's make all of this and shadows. Let's make just all the meshes the same. So this will allow you to really display practically everything about your shading. And from those of you who are trying to create virtual reality, or who are creating virtual reality in the gaming engines, we can actually use shaders like the new materials, like Unity and Unreal materials, that I can easily export directly to the gaming engines, and the shaders will rebuild on the gaming engine side just by pretty much exporting directly to a engine of my choice, and I can hit export, and with one click of a button, it will reappear in the engine directly, and you can use it there. So that was the other release, but the one that makes me probably the most excited. I think it's the most exciting, and I find it particularly useful, is the addition of procedural modeling, and that came in the fairly recently in the year. And that allows you to essentially create smart assets and repurpose parts of your modeling. So if I start with something fairly simple, and then we'll have a look at, never happened before. I'll just relaunch this. And to give the computer a little breathing room, I'll close NUKE as well. So I'll just start with something really simple. So the procedural modeling allows you to, previously in MODO you could create the objects only in a linear fashion. If I created a primitive or anything inside of the application, it was there was no way of changing it. But now we have the procedural approach, so I can start creating everything from scratch in entirely procedural manner. So let's just add something like a cube. That will drop a cube into my viewport. provided actually create one. And, sorry, cube. And I'll get a fully procedural object inside of the scene. So anytime I would like to change something about this, I can just return to this. And from this moment on, I'm starting building a procedural system that is adjustable completely. So let's say I'll give it 20 subdivisions. And then I can add something like delete node. That can be done on selection or just generally, so I'll just add the delete again. And now the whole mesh will disappear because there is no selection, so there is no filter. I can add some type of selection. Either I can do it before, just select a few meshes, or I can say select by fall-off. And then I just need to give it a fall-off. Like, for example, radial fall-off. Now I have a sphere that will erase pieces of the mesh procedurally. You can invert this, animate this, rig it up. So let's say I will use a different type of a setup. Let's say I would like to use texture-based fall-off, which might be really handy to create patch walks and anything that would take some time to create. So if I give it a texture, like puffy cloud, now you can see that the texture is actually erasing parts of the mesh. If I play with the bias, I can adjust how much, and another operation might be the thicken. So you can combine all these tools that are available to you as a nodal and stacked operations directly inside of MODO, and everything is adjustable. I can go back down to the cube and change maybe the subdivision level to something like 10, and it will all reprocess itself procedurally. So this was a very simple and basic example of the procedural modeling itself. But if you want to actually apply this or use this in actual production, this is particularly handy for to create a smart assets. So here I have a example of something like that. And this is a roof builder done through procedural modeling, and this can be used from project to project. So I have my little controls, and I can start extending the roof tiles. So let's say I'll just dial in the length of the desired roof, so maybe something like this. Then I can dial in the amount of tiles in the Z direction and add the pitch. Very easy. I can, to maybe enhance a little bit of realism, I can add a random scale and slight random twist to this. And for fun, pretty much using the same technique as previously, by erasing certain bits, by using texture, I can dial in some destruction on the roof if that's what you're creating. All of this can be frozen, exported to other application if you're using something else to render. But the procedural modeling opens up completely whole new world of how to approach modeling process inside of MODO. Cool, so this kind of concludes the MODO section. Do we have any questions in the room? Cool, well, thank you for your time.